Today we're solving problem 21 from the Spring Amc 10B from 2021. A square piece of paper has side length 1 and vertices A, B, C, and D in that order. As shown in the figure, the paper is folded so that vertex C meets edge AD at point C prime and edge AB at point E. Suppose that C prime D is 1/3. What is the perimeter of triangle AEC prime? Well, first of all, we're given this is a square sheet of paper and it's folded like this. Since it's square, these two have to be right angles. So we are given that C prime D, this segment is 1/3. Well, yeah, it's 1/3. Okay. We can also find the length of segment AC prime because we were given that this is a square and the total length of one side length is 1, so 1 minus 1/3 is 2/3. Okay, now we want to find the perimeter of AEC prime, this triangle there. Okay, well, we can do that, yeah. So, first of all, we can actually set up a system of equations for this since we can use the Pythagorean theorem. Okay, so first we see that we can find this side length using the Pythagorean theorem because we have, let's just set this side length to be x. Okay. Now, this is x, then this segment from this point to C has to be 1 minus x. And therefore, if this is folded over here, it's kind of tricky. But if you're folding a paper to another point, this segment is going to have the same length as this segment, so this is also 1 minus x. It's like, if you're doing this in real time, you'll see that this is, in fact, true. Now we can use the Pythagorean theorem on this triangle. X squared plus 1/3 squared is 1/9. This is equal to 1 minus x squared. X squared plus 1/9. This is 1 minus 2x plus x squared. We can cancel those x squared, so we get 2x is 8/9. X is 4/9. So what we just solved for was the length of this segment x, which is 4/9. Therefore, this segment here, 1 minus x, this is really 5/9. Since that's 1 minus x, this is also 1 minus x, 5/9. Cool. But what does that do us? Oh, and also you can notice this is a 3-4-5 triangle, because if you convert this to ninths, this is 3/9, 4/9, and 5/9. Just wanted to point that out. But getting back to the problem, why did we just solve for that? Well, we notice that we solve for that is because these two are similar triangles. That makes more sense, but like this is a right angle, just to be sure. And these two are similar triangles by similar angles, angle, congruency postulate. And we can also find the scale factor, or the ratio, I guess, for this one. So, C prime D over A prime C, A C prime, this scale factor this is going to be 2. Well, it's not really a scale factor because those two sides aren't corresponding, but we can sort of find the scale factor for this problem. If they are similar, so actually A, C prime, and D, whatever this segment is, they correspond because, well, you can figure that out, but I'm just telling you they correspond. We have to convert this to ninths. Since you can't convert this to ninths, I just like to do it to make more sense. So this is 6/9. Okay, so it's a 6-to-4 ratio, or a 3-to-2 ratio. So for any given side length or value from this triangle, multiply by 3/2 to get this side length. So using that logic, we can multiply 1/3 times 3/2. This gives us 1/2. What did we just solve for? This side length, C prime D, is 1/3. You use the scale factor, which is 3/2 for this triangle. This is 1/2. And the side that corresponds to C prime D is AE, so this is 1/2. You can use the Pythagorean theorem or the scale factor, 5/9. I'm going to use the scale factor because it's easier. 3/2, 1, 3. This gets us 5/6. So 5/6 right there. Okay. Now all we want to do is add all the side lengths up of this triangle. So we get 2/3 plus 1/2 plus 5/6. Okay. Well, yeah, you can just solve for this again. This is 2/3. This is going to be over 6 because we want a common denominator, 8/6. This would be 12 over 6, but that's just going to be 2, and our answer is 2 because that's the perimeter.